Hello everyone, this is Wasim from Edureka and I welcome you all to this live session in which I'm going to talk about the third project that we are going to do in this part 3. But before that, let me get a quick confirmation if you guys can hear me or not. So if I'm audible to you guys, please type yes in the chat box. And now that I'm getting a lot of confirmation, let us take a look at the agenda for this session. So now a lot of people must have heard about the data science project for credit card anomaly detection using machine learning classifiers. And it is one of the best projects that you can begin with as a beginner. And it is a large data set and builds a foundation for any budding new learner as a data scientist. So in this session, we will build one credit card fraud detection classifier using Python. So without any further ado, let us begin our session. So first of all, we need to understand the need of working on this project. I mean, why do we actually need it? So you have to make sure that companies are pretty vigilant in terms of detecting all these anomalies in fraud detection because they don't want their customer to suffer for any illegal transactions that are happening just because somebody else can get away with it. So they have to make sure that they're keeping track of all the data and they're able to identify the illegal transactions, or you can also call it as fraud transactions. So the dataset that we are going to work on contains transactions made by credit cards. It's European card holders basically, and the dataset presents transactions that occurred in 2 days. So where we have almost 492 frauds out of all these transactions that we are going to see when we explore the dataset. And the dataset is quite unbalanced, and the positive class account for only a few percent of the transactions, and most of them are normal transactions. So we have to identify those fraudulent transactions which are very less in numbers. And it contains only numerical input variables, which are a good thing. So you don't have to worry about changing the object type or the data type of some variable into another. Due to the confidentiality issues, of course, they have not provided the original features and the background information about the data. So the data basically has features V1, V2, etc. until V28, which are the principal components obtained. And the only features which have not been transformed are time and amount. So feature time contains the seconds elapsed between each transaction and the first transaction in the dataset. The feature amount is basically the transaction amount. So the transaction amount feature can be used for example, dependent cost sensitive learning. And the feature class is the response variable, and it takes value 1 in case of fraud and 0 otherwise. So we'll begin our session, guys. We'll jump directly to the Jupyter notebook and we will start our session over there. So I hope you are clear with the objective of this session, guys. So we are going to work on the dataset and we are going to make a classifier to check for the fraud detection or the anomaly in the dataset. So first of all, what we have to do is we have to install a few dependencies first of all. So for that, to import a dataset, I think you guys must be sure about this. We have to import pandas as PD, and we will import Seaborn as SNS for visualization. We'll import NumPy for calculations, numeric calculations, and we'll import these libraries for now, and we will import the other dependencies when we need them later on in the session. So don't worry, guys. So the first thing that we have to do is import the data using PD read CSV. And I'm sure most of you must be wondering what kind of data I found this from. This is basically I found this data on kaggle.com, and you can just type there credit card fraud detection because this is a very common or a generic example that people work on. I'm telling you about this example because it builds the foundation and it actually tells you how you can segregate the data and understand it in order to make calculations or predict the outcomes. So first of all, we are going to start with importing or loading the dataset into our program. So I'll copy the path and I think we're good to go. Yes. And now I take the first look at my data, guys. All right. So we have time, V1, V2, V3, and all these columns. Like I have 5 rows and 31 columns, which has in the end amount and class. So class 0 basically means it is a normal transaction. I mean, if it is 1, it is fraudulent. So we'll check for the tail as well. and only a very few of the transactions are actually fraudulent. That's what we have to make sure that you're doing right. So first of all, I want to segregate the fraudulent transactions from the normal ones. So I'll take one variable, let's say fraud, and I will use the data.loc. I'm sure you must know what loc actually is doing right here. It is locating the values that I'm going to provide over here using the column class for all the values which are equal to 1. And for non-frauds or the normal ones, we'll take the variable as normal, and we'll do the same thing, data.loc data class is equal to 0. So we have our data, guys. Now let's print fraud. Wait a minute. So we have 492 fraudulent transactions, so we'll just get the count. Or we can get the sum as well. And for the non-frauds, we can just get the length of the fraud as well. So this 492 and length of normal is 2,84,315. This is pretty clear to you guys, I guess. Now we're going to do some EDA. So we're going to plot a few graphs to understand the relationship between all these variables. And I'm sure most of you must be wondering what we are going to use. And we're going to use the Seaborn again, relation plot. And inside this, I'm going to get the features, amount, and the class. So for X, I'm going to provide, let's say, amount. And for Y, I provide class. Data is equal to data. Right, so we have our plot here. Okay, all right, so we should take class in hue, guys. So for Y, I will write time, and hue is equal to class. This should be fine now. We're gonna get the data segregated into fraud and normal. It's taking a while because the data is very large. Earlier in the previous sessions, the data we used were not that large, but the amount of entries that we have in this, inside this data set, you can imagine there's a very large data set, and as you can see in the plot as well. Since the fraudulent transactions are only 492, you can barely even see those yellow dots over here because of the number of normal transactions that we have over here. And after this, we can get a few more visual graphs to understand the relationship between these variables. So instead of amount, we'll keep the amount, and let's just keep frauds over here, and the hue should be nothing for now. Let's see if we have any errors. Okay, we have errors, guys. Could not interpret the because it's fraud, I guess. All right. So we'll try to make it interesting, guys. We are going to use the category plot, and let's see what the output is, because we'll get the graph into two categories in which we are going to get the class as fraud and not fraudulent, and there'll be the entries for amount and time. It's taking a while, guys. So meanwhile, I just want to tell you guys for this particular program that I'm showing you here, we are going to use the logistic regression, and the data is quite unbalanced, so we'll try to keep the accuracy rate to the highest. So that's our goal for now. And after we are done, okay, there's nothing really to understand with the visualization in this particular program because we already know the number of fraudulent transactions. Okay, I'll just stop this, and wait, I'll just remove this because it's taking us a lot of time. I'm just going to remove this and run all the cells again so that we can move on with the session, because these visual representations will only tell us so much, and we already know that. So what we are going to do is we are going to use the logistic regression first of all. So for that I'm going to import a few dependencies, like I am going to use from sklearn dot from sklearn I'm going to import linear model. Okay, no module. All right. And after this, we want to import a few more dependencies, like from sklearn dot preprocessing, and we want to import. Right, we will skip that part and we will import the train test split. All right, so I think this is going to be enough for now, all these dependencies, and we have to segregate our data in the form of x and y so that we'll be able to put it inside the train test split method. So for that I am going to write x as, so for this I want only the values, and for y, wait a minute, and for y I want the values, the target variable only, which is class. Right, so df is not defined. All right, sorry guys, I was practicing this with the name of the data as df, so that's why I've been writing df for a while now. I'm sorry for that. So we have actually segregated the data now, and now what I'm going to do is I'll write x train, x test, y train, and y test, and I'm going to use the train test split method, and inside this I'm going to provide x and y, and I'm giving the test size is equal to 0.35. We can get the test size as anything that we want. Really, it has to be in a proportion that you want your test size to be, like how much data you want to train and how much data you want to keep for testing. So that's about it guys, and now I am going to use the, all right, let's say classifier is equal to linear model dot, and we are going to use a logistic regression here guys. I'm going to provide the C as a 1E and 5. So we have made a classifier, and now I'm going to use the classifier to fit the model, which is x train, and so we are going to fit the model now. All right, we have a warning ready, so it's done guys. Now we're going to use the predict method guys, or for that we will take y predict, and we'll use the predict method guys. So for that clf dot predict, and this has to be x test. All right, now we take one more value guys. So we are done with the model also guys now, and so there might be a few problems. I'm just going to use the np array in this so that we don't find any problems later guys. And I'm going to take one more variable inside this. I'm going to put the y test. Right guys, now we're going to check the accuracy, and before that I want to check the confusion matrix. Right guys, so now what we're going to do is we are going to check for the accuracy score and classification report. So for that I am going to import a few dependencies, and these are the dependencies that we need, which is metrics, and inside this we want confusion matrix, classification report, and accuracy score. So guys, we'll check for the confusion matrix first of all. And inside this we have to put y test and y predict. So this is our confusion matrix. All right guys, and let's check the accuracy score as well. So our accuracy score is pretty good guys, and when we are going to check in the classification report, it might as well just show us as 100% accuracy. So let's check for the accuracy in classification report as well. Right, so we have the precision, recall, we have the FN score and support as well. And for the confusion matrix that we have over here, we have the true negative and the true positive. Or to get a clearer picture guys, we can do one more thing. So we had made this array, NP array of y test. So instead of y test, we're going to use y. And let's see what the output is. It's almost the same guys. And if we check for this as well, the accuracy score is actually better. And if we change it for this, all right, so this is how you make a classifier to make a credit card fraud detection. Although this is a very basic project that I've shown you guys. So we load the data and then we look for the insights that we can find from exploring the data. And then we do a few of visualization to understand the relationship between the variables. And after that, we segregated the data. This is our target, and this is the training data that we have. And then we use a logistic regression model inside which we are getting the confusion matrix like this, the true negative and the false positive on all those values that we have, which is basically, I'll tell you guys. So inside this we have the true positive, there is a true negative, the false positive and false negative. So for the true positive we have 101 values, and for the true negative we have 99491 values, and for false positive we have 42 values, and for false negative we have 49 values. So this is about the confusion matrix that we have, and we can actually reduce the false negative rate if we use other techniques inside which we can add some noise to the fraud data to create more and reduce the imbalance, because this is a quite imbalanced data. And this is just to tell you guys how you can go ahead and make a fraud detection regression model using the logistic regression in Python. And you can also randomly sample the fraud data and train the K models and average them out. So if you want to learn more about these logistic regression models and or linear regression and the classification algorithms that we have in machine learning, we have all the data and all the tutorials that we already made on YouTube. You can find it on your YouTube page, and we have made a lot of projects using these classification algorithms. And also tell us in the comments what kind of projects do you want us to make in the next upcoming sessions, so that you'll be able to understand it better. And now that we have come to the end of the session, don't forget to subscribe to Edureka for more exciting tutorials, and press the bell icon to get the latest updates on Edureka. And do check out Edureka's data science for Python certification program. The link is given in the description box below. And one more thing I want you guys to do is, so we have found the classification report, the accuracy score and everything. I just want you guys to test it out, like get a few values from this data. So basically the target is the class over here. That is what we are actually predicting, right? And in the previous session that I did, we had also tested it, like to get the values. I'll show you guys where is this is my session 2 project that I did. So in the last we had these accuracy score like of 0.85, which is for our model is 0.99, which is basically very high. So you can take few values from the data set, use it, and using the classifier try to predict the value if it's a fraudulent transaction or if it's not. So this is one exercise that I'm giving you guys, and stay tuned for more sessions like these. And also tell us in the comments what kind of projects are you looking forward, and tell us what you want us to work on next. Thank you and happy learning.